It's just 2 review days because it makes absolutely no sense for us to test the not day before a 5-day weekend.
Well, I appreciate it.
I appreciate that we're on schedule.
Okay, so today we're continuing forward with solving. But today's problems are going to have something a little bit different involved in them. In order to solve, what did we use last week? Unit circle. Today you're going to need both the unit circle and your identity sheet. Because the reason that we work with these identities is because of the fact that sometimes you actually need to use them to manipulate the equation to get something that you can solve. For example, cosine of 2 theta plus cosine of theta plus 1 equal to 0. And we're going to solve it for the range for all theta in degrees. Generally speaking, our goal in solving for trig is to get a single trig ratio equal to a number. But when those trig ratios have different angles, we've got a problem, such as this. So we need to get down to having the same angle throughout the problem. That angle could stay 2 theta, or it could change to regular theta. More commonly, it's regular theta. The only time it really stays 2 theta is if that's really the only thing going on. So I need to change cosine of 2 theta into something that only has regular thetas. Cosine of 2 theta, I got 3 options. Which option do you think is best to work with an equation like what we have? Second one? What was your thinking? It's the only one that's only got cosines in it. When we're solving, do we typically want sines and cosines, or do we want just a single trig ratio? Single trig ratio. So I would agree 100% that I'm going to use the second one. Now, when you replace a single term with a double term, it needs parentheses sometimes. Technically not all the time. Will it make a difference if I put this here in parentheses or not? In this problem, no, it does not. When does it make a difference? When it's being multiplied by something. If this was 3 cosine of 2 theta or a negative cosine of 2 theta, I would have to distribute that negative or that 3 to this. There's nothing being multiplied by this. So I just straight up change it out. 2 cosine squared theta minus 1 plus cosine theta plus 1 equal to 0. Combine like terms. Negative 1 and 1 cancel out. 2 cosine squared theta plus cosine of theta is equal to 0. Now, things that we use to our advantage for solving. If there are multiple things involved, like this one, where there's more than just a cosine, generally factoring is going to be our friend. Factoring only works in solving if it's equal to 0. Can we factor this? If you're not sure, once it's to a single trig ratio of the same angle, you can always change it into x's and see how you would solve that equation. Could we factor this to solve? Yeah, you'd factor out an x. It'd leave you with 2x plus 1. Then what? Set the terms equal to 0, because the only way you get things multiplying together and giving you 0 is if you multiplied by 0. I get x equals 0 and x equals subtract 1 divide by 2, negative 1/2. Now I didn't have to change it to x. I could have dealt with those in this way, but you do need to remember, it wasn't x we were solving for. X replaced cosine. Nor was it cosine that we were solving for. It was theta. If cosine is 0, theta is equal to what angle? "90 degrees. I know I'm working in degrees because it says degrees. Where else? 270 degrees. Anywhere else? No, so I look at the other one. Where is cosine of negative 1/2? $120 degrees, is that what I heard? Where else? 240 degrees. Are these my answers? Look at the range. For all theta in degrees. When it says for all theta, that's when I do what to the answers? Plus 360k, where k is an integer. I make sure I get all the coterminals involved as well. This is when I could possibly simplify down. It's only in the situations where it's for all theta. In this case, could I simplify any of these down? Yes, I could simplify the 90 and the 270 into 90 plus 180k. Do you need to do that? No. If I do that, make sure I do not forget that these two still are technically answers. They just don't simplify down. Sine of 2 theta is equal to cosine of theta for theta between 0 and 2 pi. What's the first thing you notice? 2 theta. Sine of 2 theta. I don't like it. I don't like having theta and 2 theta. 2 theta can change to theta pretty easily. Sine of 2 theta becomes what? 2 sine cosine. How do we solve one like this? There's technically 2 ways to solve it. We talked about one way on Friday. One option is if you notice all the terms divide by something, you can divide by it. I'm not going to do that way this time. I'm going to show you the other way. Get everything onto one side. Get it equal to 0. Just subtract cosine theta. Can I actually subtract cosine from 2 sine cosine? No. I just write 2 sine cosine. Of course, with the thetas, equal to 0. This is almost like having 2xy minus y equals 0. Yes, you can divide by the y. That's the method that we talked about on Friday. Or the other option, factor it. I can factor out a y, leave me with 2x minus 1. Or, if you prefer, factor out a cosine. My factors have x and y separate, so I can set them individually equal to 0. I get y equals 0 and x equals, add 1, divide by 2, 1/2. But I change it back into my trig. What did y take the place of? Cosine. So cosine is equal to 0. Sine was x. Sine of theta is 1/2. Where is cosine? 0. Not 90 and 270. Look at the range that I asked for. Pi over 2 and 3 pi over 2. Where is sine 1/2? I heard both pi over 3 and pi over 6. It's not possible to be both of them. Which one is it? Pi over, make sure you're looking at the y values. 6. And pi over, sorry, the next one's not actually pi over, it's something. Pi over, 5 pi over 6. If you had divided both sides by cosine, would you have gotten the same thing? Technically, yes, but no. You would have gotten this part. Remember, when you divide by something, you also have to take into the account where it is equal to 0, because you couldn't have divided by it had it been 0, and 0 would give you another solution. Next one tends to be a curveball for people. Guys? Sine of 2 theta equal to 1. For theta between 0 and 360, not including either of them. First thoughts. Sine 2 theta can become 2 sine theta cosine theta. How do we solve that? Get it equal to 0, okay. Subtract the 1. 2 sine theta cosine theta minus 1 is equal to 0. Now what? Can you factor this? Nope. It has solutions. It's not no solution. Look at the original problem. Do you notice that the only angle is 2 theta? Which means staying as 2 theta is not necessarily a problem. This didn't help us this time. Let's go back to the original. Sine of 2 theta is equal to 1. It's our original problem. How would you typically get theta alone? You do inverse sine at this point. On this side, I'd be left with 2 theta. On this side, I'd be left with sine inverse of 1, which is what we've been doing when we've been looking at our unit circle saying, where is cosine of theta equal to 0? Technically, we're doing cosine inverse of both sides. This side's left with theta. This side is, we're just using the unit circle to do the inverse trig. I can do inverse trig. I can use my unit circle to do inverse trig. Where is sine equal to 1? $90. So 2 theta is equal to 90. Divide by 2. Theta is 45 degrees. There's only one problem. This is a solution. But it's not the only solution. When I do inverse trig, specifically inverse sine, the calculator, which is oftentimes what we use, would give me values between negative 90 and 90 as a result. We use the unit circle because the unit circle gives me values between 0 and 360. It expands our range, but it expands the range for theta. When we did inverse trig, were we doing inverse trig to get theta? Just theta, specifically. I did inverse trig right here. It didn't give me theta, it gave me 2 theta. This is where theta is located. If theta is between 0 and 360, where is 2 theta? How do you change from theta to 2 theta? You double, you multiply by 2. If theta is between 0 and 360, 2 theta is between 0 and 720. Which means when I do inverse trig, I not only need to look at angles between 0 and 360, I need to look at angles between 0 and 720. Where else will sine be 1 between 0 and 720. $90 and I have no clue what you said. Nope. That's what tangents are. Technically it's negative. Closer. Starting with the 90, not with the 45. Do what you did, but with the 90. $4.50. Sine will be 1 at 90 and any angle coterminal to 90. So when I do my sine inverse of 1, I can also look at angles coterminal to what I get. And then I divide by 2, and I get 225 degrees for theta. Is that still within the range that I wanted for theta? Yes. So, if getting it down to regular theta becomes a problem, you can still solve as if it were 2 theta, but you have to adjust your range of things that you get out of the unit circle to include things that are coterminal. Sine squared plus 2 cosine squared is equal to 4. What's the first thing you notice? We got some squared trig. Cosine squared and sine squared. What do you know about cosine squared and sine squared together? They add up to 1. I don't exactly have sine squared plus cosine squared, though, do I? I have sine squared plus 2 cosine squared. Can't divide. But I can break it into 2 cosine squareds. That way, now I have sine squared plus cosine squared, which is 1. Now what? I could get it equal to 0. That's not the best option here. Do you notice that you've got trig squared and that's the only place you got trig? It's kind of like having 1 plus x squared is equal to 4. Easiest way to solve it is using square roots. get the squared part alone. X squared is equal to 3. To get rid of a squared, you take square root. When you introduce the square root, what do you need to introduce with it? Plus or minus. X is positive or negative. Square root of 3. Can I simplify the square root of 3? No. I change it back. It was never x. It was cosine of theta. Cosine is equal to a positive or a negative square root of 3. Where is cosine equal to the square root of 3? We are finding theta. Nowhere on the unit circle. Does that mean absolutely nowhere? No. Could be other angles. How could I find the angle if it's not on the unit circle? Inverse cosine. Treat the positive and the negative as two separate equations. Cosine theta is equal to square root of 3. Cosine theta is equal to a negative square root of 3. I can do inverse trig. I can do calculator inverse trig still. Inverse cosine square root of 3. This is not an angle on the unit circle. That does not mean that it doesn't work, but I did inverse trig in my calculator, and does it work? No. What's the biggest that cosine gets? 1. What's the smallest it gets? -1. Square root of 3 and negative square root of 3 is not within the range. It's not within the domain of inverse trig. So in this case, it is no solution. So, but it's not guaranteed to be no solution just because it's not on the unit circle. Only got like 5 more left.
Are you actually serious?
No, it's not 5. Clearly 4. Yes, of course. Secant squared minus tangent to the 4th is equal to -1. Thoughts? Can I just change what? You can switch to sines and cosines. I would not have advised that direction. Is there some other connection between secant and tangent? Especially to powers?
Yeah.
Secant squared, for example? Pythagorean identity? Secant squared is tangent squared plus 1? When I turn a single term into a double term, it needs parentheses. Okay, now it's all tangents. I'll probably distribute. By probably, I mean I'm going to distribute. Now it's at least all tangents. But what the heck are we supposed to do with this? Since it's all tangents, I can switch it over to a variable now to make it easier to look at. I heard someone say get it equal to 0. I like that. While I'm at it, I'm going to write it in standard form. In other words, exponents decreasing, because we typically like x squareds, then regular x's, then constants. Or in this case, the biggest exponent is x to the 4th. Can we factor things with higher powers than 2? The answer is yes. You did it back in advanced algebra. To factor something with a higher power than 2, you can factor it if it can be written as a quadratic-like form. A quadratic-like form. So quadratic form, straight up quadratic, is ax squared plus bx plus c. Quadratic-like, still going to have the 3 terms. That's got 3 terms. And the requirement is that that first exponent is double that of the middle exponent. Do we have that happening? Yes. So we can almost treat it as if this was this, where I replaced x squareds with y, because x squared getting squared is to the 4th power. So I just turned x squareds into y's, and now I can factor it as if it was negative y squared plus 2y plus 3 equals 0. As is, I would have to do full AC method. But I can factor a -1 out of everything, so I'm going to do that first. Now I can do the shortcut. 2 things that multiply to -3 but add to -2. Multiplies to -3, adds to -2. -3 positive 1. But it was never y. What did y replace? X squared. X squared minus 3 is equal to 0. X squared plus 1 is equal to 0. X squared is equal to 3. X is equal to positive negative square root of 3. X squared is equal to -1. Square root that, and I'm going to get imaginaries. Have we been dealing with imaginary numbers in trig? That one's not helpful. X is positive and negative square root of 3. But it was never x. It was tangent. Tangent of theta is equal to a positive and negative square root of 3. Where is tangent either a positive or a negative square root of 3? 120, 60, 240, 300. Is that my final answer? For all theta and degrees, get your coterminals in there, plus 360 degrees K, where K is an integer. There's one more problem I want to do. Okay, I'm skipping one of the problems. Down to just one. Because this one problem has something in it that I haven't talked about yet. Actually, it's got two things in it that I haven't talked about yet. Cosine of theta is equal to 1 minus sine of theta. Sometimes the relationship between the trig ratios that's going to get you where you want to go is not obvious. Tends to pop up in ones like this. Because my angles are the same, so I can't just automatically go to like a double angle identity or a sum or a difference identity or anything like that. Cosine and sine are related in a lot of ways. One way is tangent, but tangent's not involved. So that's going to make things harder. Another way that cosine and sine are related is through the Pythagorean identity. But what does the Pythagorean identity require be true of your trig? Squared. Can I square equations? Yeah, if you do it to one side, you just got to make sure you do it to the other. So I can square both sides of my equation. On this side, it's really easy. It's cosine squared theta. How do I square 1 minus sine? Hint, it's not 1 minus sine squared. I have to square the entire thing, which means I'm putting it in parentheses to square it. And to square a binomial is to multiply it by itself. So I FOIL that out. 1 times 1 is 1. 1 times negative sine is negative sine. Negative sine times 1 is negative sine. Why did I write a squared on that? That's not squared. And negative sine times negative sine is positive sine squared, in which I can now combine my like terms, in which there are 2 sine of thetas. I did that so that now I have squareds. So now I can use the Pythagorean identity. Probably makes more sense to switch cosine into sines. Cosine squared is equal to 1 minus sine squared. I combine my like terms. The ones cancel out, and I have 2 sine squareds. How do I solve something like this? Factor. Greatest common factor. 2 sine. Get -1 plus sine of theta. It's equal to 0. It has to be equal to 0 for factoring to do us any good. And I split. 2 sine of theta equal to 0 means sine is 0. -1 plus sine of theta equal to 0. Add the 1 and sine of theta is equal to 1. Between 0 and 360, sine is 0 degrees, 180 degrees, and 360 degrees. Sine is equal to 1 at 90 degrees. I mentioned that this problem had 2 things you hadn't seen before. These are not the answers. At least not all of them. Because one of the things we haven't talked about, and it doesn't show up very often, but it does show up in situations where you are squaring both sides of the equation. When you are squaring both sides of the equation, you are ignoring the original domain and range of the equation. Extraneous solutions can come out when you square both sides of the equation. What are extraneous solutions? Oh, we talked about it before. It's been a bit. Extraneous solutions are solutions that you got by going through the solving process. Everything worked, but when you plug them back in, they don't actually work. Essentially, you got to check your solutions. Plug them back into the original equation. Now, since the original equation's got theta in 2 places, I've got to plug it into both sides. Cosine of 0, 1 minus sine of 0. I get the same thing? That's an answer. Cosine of 180, 1 minus sine of 180. That's an extraneous solution. If 0 worked, 360 will work. It's the same location on the unit circle. Cosine of 90, 1 minus sine of 90. You get the same answer on both sides, you're good. But you should check for extraneous solutions anytime you square both sides of the equation. Okay, that is it for notes. Part of the reason why I give you 2 review days is because I know that solving tends to trick people up because it's got a lot of different things. So, solving, we're on page 904. This section is really broken up, so it's a lot of like individual problems. 3, 15, 16, 22, 23. A nice solid section of 30 through 40. 42 and 43.